Hey there, this is to supplement Chapter 6 where we're learning the time value of money. And the concept here is to review algebraically what we learned yesterday. What we learned yesterday as an example is that if we want to solve for an annuity problem of, say, the future value of an annuity, what we were doing is we were taking the number of pays and the interest rate factor, and we're using that in order to get to the table amount, which would give us our total factor to multiply times the dollar amount of payment. That was a straightforward future value of an annuity, and it came in two varieties. It came in the variety of a ordinary annuity, which is the tables themselves, and then if you had an annuity due, you adjusted the tables in the way we described yesterday, and you can find it in your book, how we adjusted the table. Okay, so that's the straightforward concept. Taking this into account and sort of moving it up the ladder here. Let's see, I think we can, there we go. So remember this, if we move it up the ladder, what we can now do is, in the event that we know the future value, so this becomes the known, we know this, but what we don't know is this becomes the unknown. Just like any algebraic equation, we can solve for the unknown here by doing a little bit of manipulation of the traditional methodology that we learned yesterday, and that would be the following. Fair future value becomes known, so now we have a dollar amount for that, for the future value, equals, and we'll call this, for now, we'll call this whole thing, this whole contraption, the factor. Of course, you can see what the factor is made up of. It's made up of the number of pays and the interest rate. But for here, we'll call it the factor times, and now we'll call this y, the unknown, which is the amount of pays per period. So if the future value is known, what we'll do, in order to solve for y, we're just using algebra now, and there you go. Now you have a way of using the same information we learned yesterday and solving for y. In this case, y being the amount of pays per period at the interest rate, or I should say the dollar amount of the pay. This concept using algebra applies to all of what we learned yesterday, so you may have to kind of figure out the initial equation of what we learned yesterday in order to be able to do it in a way that solves for unknown factors. Alrighty, and that is what I wanted to let you know, is that you can take any of the ideas that we learned yesterday and switch around and saying, well, what if we already know the present value or the future value? How can we solve for any of the other issues in this equation? And I do mean any of the other issues in this equation. Using the tables, we could solve for the number of pays, we could solve for the interest rate, the pay amount, or the future value, or if it's a present value problem, same way we can solve for any of the issues just by using a little algebraic ingenuity. Of course, one last thing, just to show you what I was describing at the end of class yesterday, is that your financial calculator comes equipped with, in most cases, comes equipped with buttons looks like I'm run out of room here, but the buttons will be N for the number of periods, I for the interest rate, P for the payment amount, then there would be present value and future value. And if you know any of 3 or 4 of these, you can solve for the unknown by putting in what you know and then asking the calculator to solve for the unknown, and the calculator will do it pretty much automatically. You just need to be able to program your calculator for whether it's a ordinary annuity, if you're doing annuities, or an annuity due. So it will know how to calculate whether the payment's upfront or at the end of the period. And that is that.